Hello and welcome to this video on differentiating x to the power of n. In the previous video, we saw how to use differentiation from first principles to find an expression for the gradient function, and you can be asked to demonstrate that process in the exam. Thankfully, however, there's a quick way to differentiate terms of the form x to the power n, where n is a constant, without having to use first principles every time. So, if y equals ax to the n, where a and n are constants, then dy by dx is nax to the n minus 1, i.e. we multiply by the power, which was n, and then we reduce that power by 1. So we're going to look at some worked examples. In our first worked example, we have y equals x to the power of 5. So when we differentiate that to get dy by dx, we multiply by the power, i.e. we multiply by 5, and we reduce the power by 1 to get 4, so the answer is 5x to the power of 4. For the second one, y equals 4x to the power of negative 7, we multiply by negative 7, which gives us negative 28, because 4 7 is 28. Reducing the power by 1 gives us negative 8, so the answer is dy by dx equals negative 28 times x to the power of negative 8. And using the other notation, f of x, if f of x equals x to the power of a half, then when we differentiate that, we can get f dash x. So timesing by a half just gives us a half as the coefficient. Subtracting 1 gives us negative a half, so the answer is half x to the negative a half. 3 more worked examples. So if y equals 2x to the power of 6, we multiply by 6, which gives us 12. 6 take 1 is 5, so the answer is 12x to the power of 5. The next one says f of x equals x divided by x to the power of 4, which is the same as x to the power of negative 3 when we subtract the indices. So to differentiate that, we multiply by the power, which gives us a coefficient of negative 3. Negative 3 take away 1 is negative 4, so the answer is negative 3x to the power of negative 4. And then finally, y equals the square root of x to the 6. Now, when you square root a term with indices, you're actually halving the indices, because x cubed times x cubed is x to the 6. So y equals the square root of x to the 6 is simply x cubed, and when you differentiate that, we times by 3, take away 1 from the power, and we get 3x squared. Our final set of worked examples include roots and fractions, and in both cases, we need to rewrite the term in the form ax to the power of n. So for the first one, we have y equals 2 root x. Now, as we know, the square root of x is x to the power half, so we can rewrite that as 2x to the power of half. And then when we differentiate it, 2 times a half is 1, so the coefficient is 1, which we don't write. Subtracting 1 from a half gives us negative half, so dy by dx equals x to the power of negative a half. The second one says y equals the cube root of x, which is x to the power of a third. So we multiply by a third, and we subtract 1 from a third, which is negative 2/3. So the answer is dy by dx equals a third x to the negative 2/3. If f of x equals 8 over x squared, that is the same as 8x to the power of negative 2. To differentiate that, we times by negative 2, which gives us negative 16. Subtracting 1 from the index gives us negative 3. So the answer is f dash x equals negative 16x to the power of negative 3. And then finally, if y equals 6 over the cube root of x, that's the same as 6x to the negative a third. Multiplied by negative a third, we get negative 2. Negative a third to take away 1 is negative 4/3. So the answer is dy by dx equals negative 2x to the power of negative 4/3. Thank you very much.